All right, so in this video, we're going to learn about a rational exponent, which is the connection between the root and the exponent. And let's start with this. Let's suppose I have the x root, right? I have x root of b, right? X root of b. Now remember, this is right. Let me change color here. Remember, I have like b to the first, and here I have x, right? And I can change this one to exponent. It's going to be like b to the first to the 1 over x, right? B to the 1 over x. Right? Well, for example, if I have like square root of 3, let's suppose I have square root of 3, right? Remember, by default, I have if I have 3, that's going to be like 3 to the first, and here I have 2. So it's going to be like 3, right, to the 1 over 2. And we're going to see this one clearly when we have like, if I want to solve, for example, I want to know what's the square root of 4. What's the square root of 4? Now, if I ask you what's the square root of 4, you're just going to answer is 2, right? How we get 2? Now, we know that 4 is, we know that 4 is going to be like 2 squared, right? That's going to be like 2 squared, right? And we know we're going to have 2 here, right? So the answer is going to be, if I want to remove the radical there, it's going to be like 2 to the 2 over 2, which is obviously is going to be 2 to the first, which is going to be 1, right? Now you may ask me the question, why we have to do all this? Why we have to take long way from here to here? Simply square root of 4 is 2. But we want to practice. We want to practice the rational exponent. Okay, sometimes we need it. Sometimes we need these tools, how we answer some tough questions. And we're going to get to these questions like in this video, and you will see why we need rational exponent, right? And let's suppose I have this. What if I have like the third root of 8, right? No, we know that's going to be like 8 to the 1 over 3. Why? Because I have 1 here, right? I have 1 here, right? And we know that 8 is a perfect cube. It's going to be like 2 to the third to the 1 over 3. Now, remember, the rational exponent, right? The rational exponent is connected with exponent properties, right? And this is like the power property, the power of power property, right? When we have the base, and when we have exponent here, we have like 2 exponents here. We have the base, and we have like 2 exponent this and this, which is going to multiply the exponent. We're going to keep the base, and we'll multiply the exponent with each other. It's going to be 2 to the 3 times 1 over 3, right? Which is going to be 2 to the first, which is going to be just 2. So in general, if I have like sometimes if I have like x root of b, right? If I have like x root of b, let me just change this one, right? If I have x root of b to the x power, so in general, it's going to be like b to the x over x, which is going to be like b to the first, which is going to be just b, right? And do you remember what we said in the previous videos? I mean, we said if I have like, for example, I want to remove the radical, make sure you have the same exponent as n's root or x root here. Make sure you have the same value here, so you can remove the radical, right? And that's why we got b here. All right. So sometimes you may have a different x root with exponent. I mean, so you may have like for example, like x root of b, right, to the y to the y, right? So this is going to be like b, this is going to be like b to the y over x. So sometimes you may have like a different value. And let's get some example here. Let's suppose I have like, for example, the third root, right? Third root of 5 squared. So that's going to be like 5 to the 2 over 3, right? So as long as we can use a rule here, you can use it for any value, for any example there. It's not going to be a problem, all right? And let's get like another example here. What if we have like the square root of 3 to the 4th, right? Now remember, if I have nothing here, means I have 2 here, right? So the answer is going to be, it's going to be like 3 to the 4 over 2, which is 3 squared, because 4 divided by 2 is 2, and 3 squared will be 9, and that's going to be the answer. All right, so we're going to take these 3 examples here, 3 problems, and as you can see here, it's really difficult to solve this one without knowing the rule of rational exponent, right? So if you go to the first one here, we have third root, the cubic root of 9 to the 6th power. So it's going to be really difficult to solve it, right? So we've got to switch this one to exponent rule, right? It's going to be like by using the property of rational exponent, it's going to be like 9 to the 6 over 3, right? And we know that 6 divided by 3 would be 2, so the answer would be just like 81. So this is a really good example of the importance of using rational exponent, right? Let's go to the example number 2. I got like 9 root of 7 to the 18th power. Again, we're going to do the same thing. So that would be like 7 to the 18 over 9. And the answer would be like 7 squared, and 7 squared would be 49, right? That's going to be the answer, right? And let's go to the next one here. I got the third one. I got the fourth root of 81. So it's going to be like 81. Again, if I have nothing here, we have exponents here. It's to the first power here, right? So it's going to be like 81 to the 1 over 4. Well, now, if we know that 81, right? Because if I can find a perfect, like something to the 4th power will give me 81, that's going to be great, because if you multiply 4 with 1/4, we're just going to eliminate the fraction. We're going to eliminate the exponent there. So we know that 81 is 9 times 9, right? Is 9 times 9, right? And we know that 9 is 3 times 3. And here we have like 3 times 3. So we have like 3, like 4 times. So 81 is 3 to the 4th power. And that's going to help us here, right? So 81 is 3 to the 4th power to the 1 over 4. And remember the law of exponent that we studied before, right? That is called the power of power. So we're going to keep the base here. We're going to keep the base, and we're going to multiply. We're going to just multiply the exponents here with each other. It's going to be like 4 times 1 over 4, right? Remember, this is like 4 over 1. We can just like simplify here, and the answer will be 3, right? 3 to the 1 over 1, which is going to be just 3, right? So without knowing the rational exponent rule and the exponent rule, we won't be able to solve this one. It's going to be really, really difficult. All right, so I got this example like 6 to the 1 over 2 times 6 to the 1 over 3. We're just going to keep the base here, and we're going to add the exponents according to the exponent law, right? Additional law of exponent is going to be like 1 over 2 plus 1 over 3, right? Now 1 over 2, well, let me do this separately here, right? Now 1 over 2, right, 1 over 2 plus 1 over 3, we're going to find a common denominator here, which is going to be like 6 here. Like 2 times 3 is going to be 6. We're going to multiply by 3, and we're going to multiply by 3 here. we're going to multiply by 2, we're going to multiply by 2. Now, to find the least common denominator between 2 and 3, we need to find the multiple of 2 and 3. And I'll get back to the video of how we find the LCD, the least common denominator, and the least common multiple. And you will be able to understand how we're going to get 6 here as a common denominator here. So it's going to be like 3 over 6 plus 2 over 6, right? We get the same denominator. We're going to add the numerators here. 3 plus 2, that will be 5. So the answer is going to be like 5 over 6, right? So let's get back to our question here. So it's going to be like 6. And we just solved this one here. As you can see, that's going to be like 5 over 6. Well, according to the rational exponent law, we can switch this one to radical. It's going to be like the 6th root of, right, of 6 to the 5 power. 6th root of 6 to the 5 power. And that's going to be the answer. This is also the answer. It depends what you're going to get if you have a multiple choice question, right? So you may have like 4 answers and you're going to choose one. So at least you should know these are the same, okay? These are the same. And that's the final answer. All right, so we're taking this last example here. We get 8 to the third to the half over 64 to the half power. So here we're just going to use the law of the exponent. We're going to multiply the exponent with each other. It's going to be like 8 to the 3, right, times 1 over 2. And we know here 64 is going to be 8 squared, right, to the 1 over 2, right? So we're just going to multiply the exponent with each other for both of them. It's going to be like 8 to the 3 over 2. And here, if you multiply this with this, we're just going to eliminate the numerator with denominator. It's going to be like 8 to the first power. It's going to be like 8 to the first power, right? So by using the law of exponent for division, since we have the same base, we're going to subtract 1 from 3 over 2. It's going to be a 3 over 2 minus 1, right? Using common denominator here, which is going to be like 2. So we're going to multiply by 2 and by 2. And we're just going to get 8 of 3 minus 2 over 2. And so it's going to be like 8 to the 1 over 2. Now, by using the rational exponent 8 to the 1 over 2, it's going to be like the square root of 8, right? And we know we need to find a perfect square. We know that 8 is 4, right? We know that 8, it's going to be square root of 4 times square root of 2, and square root of 4 is going to be 2 square root of 2, right? So as you can see, we use the law of exponent, the law of rational expression, and that's how we're going to solve this one. So the answer is going to be 2 square root of 2.